Hi guys, today we're looking at rewriting logarithms using logarithmic properties. And this will be a fairly long video. I don't know a good way to split it up. So I ask you to set yourself a timer, like maybe a 15-minute timer, and pause it, take a break, and then come back. Okay, something like that. I will go through the properties. I'll go through examples. There's no homework today. However, I am going to give you some problems for you to check in the back of the book, and that would be in your best interest to do. Tomorrow you will have an assignment over this, okay? The reason we rewrite this is so that we can take complicated logarithmic equations and rewrite them to a more simpler form that we can solve in an easier way, okay? So today we will just be using 3 new properties to rewrite logarithms. Okay, so let's go ahead and look at what those 3 properties are. Okay, so remember that logarithms are exponents, and so we really should not be surprised with what our properties end up looking at or looking like. Okay, so our 3 properties. The first one is that if we have log base b of a product, okay, so if we have log base b of a product, here I have m n, okay, do you remember what happens to our exponents when we multiply bases that are the same? Okay, we add the exponents, and so this can be rewritten as log base b of m plus log base b of n. So a product of 1 becomes a addition problem. Okay, this is called the condensed version, or it's a single log, and it's a product. Okay, this is your expanded version or multiple logs. And so today we'll be practicing going from the condensed version to the expanded version, and we'll go from the expanded version to the condensed version. Okay, so that's your job today, is to go back and forth between the 2 forms. Okay. So we also had a rule for when we divided like bases. Okay, so like x to the 5th over x to the 3rd. Do you remember what we did with our exponents? We subtracted them. Okay, so when we have a division of a single log, you can rewrite it as a subtraction of 2 logs. Or if you have a subtraction of 2 logs, you can write it as a division of a single log. Okay. And then the last one is when we have a power to a power. Okay, so we have log base b of m, and we're taking it to a power. So remember, this is the exponent, so I do have an exponent to an exponent. And we multiplied those exponents. So the way we write that now is we bring the p down to the front, and we have log base b of m. So it becomes a multiplication problem. Okay, so those are our 3 main properties that we are going to use to write from, like I said, a single logarithm to multiple logarithms, or multiple logarithms to a single logarithm. Okay, we just have to follow what they ask us to do. Okay, so let's we want to write as multiple logarithms here. After I do a couple, you might want to get your whiteboard out or paper out and try them as I go, or stop my video, try it, and then check. Okay, that's what I would encourage you to do. Instead of just being passive, try to be active about learning at this point. I know it's kind of hard. Okay, but so let's say I took log base b, and then I have x, y, z. Okay, so which of the 3 rules does this one look the closest to? Okay, is it a product, is it a division, or is it a power to a power? And here we can see that it's a product. Okay, so what do we do to rewrite products? We rewrite them using addition. Excuse me. log base b, and we take our first one of x, okay, plus log base b of y plus log base b of z. We have no other operations that can be rewritten, so that is the rewritten form of log base b of xyz. Okay, so we took a single logarithm that was a product and we wrote it as an expanded form or multiple logarithms. Okay, you can also see where we might sometimes put parentheses here. It's up to you. So let's try another one. Some of them will be that basic, otherwise they get a little more difficult. Okay, so here we have the natural log of z to the third over the square root of xy. Okay, and this actually has all three properties embedded in it. Okay, so is there a property you see immediately? Well, one I see is a power, so we have a power going on. We have a division, okay. We have a multiplication down here, and then the square root is actually a 1/2 power. Okay, so we have a couple powers, we have products, and we have division. Okay, so you can start this wherever you want. I'm going to go ahead and start it as a division problem. Okay, so I'm going to take natural log of z cubed, okay, and then I'm going to take my division and rewrite it as a subtraction. Okay, minus the natural log of square root of xy. Okay, so that's one step. Okay. Different ways to go from here. I'm going to take natural log of z cubed minus natural log of, and then I'm going to rewrite my square root as a 1/2 power. Okay, when we write these in expanded form, you cannot have square roots, you cannot have cubed roots, so you do have to write these as powers. Okay, then let's go ahead and split this up. This is a product, so this is minus the natural log. I'm actually going to put a parenthesis here because that minus has to go with everything that goes on from here. This is a natural log of x to the 1/2 plus the natural log of y to the 1/2, because that's the product rule there. Okay. And then let's go ahead and take care of all these powers. So I took care of the multiplication, the division, the now it's time for the powers. So what do we do with powers? Well, they just come to the front. So this is 3 times the natural log of z minus, and let's go ahead and distribute that negative as we go. Okay, that 1/2 comes to the front as well. So minus 1/2 natural log of x. Okay, and then that negative distributes here, so we also have negative 1/2 natural log of y. So I have no more powers left. I have no more multiplication, and I have no more division, so I am done. Okay, a quick note, anytime I have something on the bottom, that should have a negative in front of it. Okay, and that corresponds to having a negative exponent, right? When we're on the bottom and we move up to the top, it's a location issue, so it just makes it negative. So you can keep that in mind as you go, or you can distribute it, whatever works for you to do that. Okay. So how about log base 5 of xy squared over z to the 4th. So this might be a good one to pause the video and try it yourself, and then come back, resume the video, and check with me. Just a suggestion. Okay, so I have a product, I have a division, and I have a power again. So let's go ahead and work through that. So I'm going to deal with my division first. Again, it's kind of up to you what you do first. But I have log base 5 of xy squared. If I take care of the division, that becomes the subtraction. So I have log base 5 of z to the 4th. Okay. And so I have power still, and I still have this product. So I'm going to deal with my product next. Okay. So I get log base 5 of x. And what do we do when we have a product? We add. So this is log base 5 of x plus log base 5 of y squared. Now, why wasn't my x squared? Well, that's because it wasn't inside a parenthesis, right? Previously, on the other problem, we had xy and it was underneath a radical, so both of those got that power. But here, the 2 is only with the y. Okay, so it's log base 5 of x plus log base 5 of y squared minus log base 5 of z to the 4th. Okay, then we need to take care of all of our powers and we'll be done. So log base 5 of x didn't have a power, but this one does, so it goes to the front. So we get plus 2 log base 5 of y, and then minus 4 log base 5 of z. Okay. And we have our expanded problem. Okay, let's look at one more, maybe. Maybe this won't be as long as I thought it might be. Okay, so let's look at number 4. Let's take log base b of x times the cubed root of y. Okay, so I just wanted to remind you, let's actually make that y squared in there. A couple of things. Okay, so here I don't have a division. I do have a product because I have something times the square root or a cubed root. I have a power, and the cubed root itself is a power. So I have a couple rules in play here. So let's, first I'm going to do the multiplication part. So log base b of x cubed. And when we have multiplication, that turns into an addition problem. So we have log base b of x cubed plus log base b of the cubed root of y squared. Okay, and so now we have the cubed root issue as well as our other powers. Okay, so log base b of x cubed plus log base b, and I'm going to write this as y to the certain power. So what power is the cubed root of a square? Okay, well, it is 2/3. So it's the inside power over the outside power. And then finally, we just need to take care of those powers, so bring them to the front. And we get 3 log base b of x plus 2/3 log base b of y. Okay, so we have no division left, we have no multiplication left, and we have no powers left. So that is going from a condensed or a single log to multiple logs. Okay, and that can be useful in some cases. Okay, and here is a challenge one for you. Why don't you try it and then come back and check with me. This is kind of just a good reminder of some powers. Okay, so we have the natural log of the cubed root of x squared times the square root of y. Okay, so what we would want to start with is maybe rewriting the square root of y underneath there. It's kind of up to you again. So I have x squared, and how do we rewrite a square root? Well, that's 1/2. Okay. And so this is the natural log. Okay, and we have what? Well, this would be x to the 2/3. Okay. And this would be 1/2 over 3, because it's inside power of the outside power, so that'd be 1/6. Okay. So I decided just to rewrite it as an exponent first. And then what do we do with products? Products turn into sums. So I have natural log of x to the 2/3 plus the natural log of y to the 1/6. And again, in our expanded form, we can't leave powers. So we have to drop our powers down. And we get 2/3 times the natural log of x plus 1/6 times the natural log of y. Okay, so that's how you deal with a power inside of a power, okay, or a square root inside of another one. Okay, so the last thing I'd like us to look at today is going the other way. So we want to write as a single log. Okay, so if you need a break, this would be a great time to go take one and then come back. Okay, another thing that you could go do right now, and maybe that's your best idea, is to go to page 407 in your book and try, looks like 23 through 41 odd. At least try some of those and check them in the back of the book. And so that is going from a single logarithm to expanded ones. Again, I don't expect you to turn them in, but if you'll check them and if you have questions, then email me, let me know, so that you're able to do tomorrow's just fine. Okay, so now's a great time for you to go try that while it's fresh, or you can go ahead and proceed through the video and then go try it at the end. But if you need a break, that's what I would suggest you go do. Okay, so now let's go look at writing it as a single logarithm. So we're just going to go backwards here. And let's take this one first. So I have 1/2 log base 8 of x plus 5 minus 3 log base 8 of y. Okay, so here I have multiple logarithms, right? I have 2, and I want to make it 1 if possible. Now the only way you can make it 1 is if they have the same base, and they do, so that's good. Okay, so different ways to approach this. I'm just going to look at here, and I see a 1/2 in front, and so when I have a number out in front, remember that means it's a power, so it's got to go here. So I have log base 8 of x plus 5 to the 1/2 power, minus, and I'm just doing a single thing here. You could do combined steps. That's perfectly fine, right? And then I have another power, and it needs to go up here. So minus log base 8 of y to the 3rd. Okay. So the next thing I see is that I have a subtraction. And what goes with subtraction? Well, when you subtract exponents, that means that we must have been dividing. So the left one goes on top, x plus 5 to the 1/2. And then on the bottom goes the right one, which is y cubed. Notice this is a single log. Don't write log here and log here. Okay, we are writing this as a single log this time. So we're almost done. The only thing that we don't like about this is we shouldn't have a 1/2 power. So what's a nicer way to write 1/2 power? Okay, and that's the square root. So we have log base 8 of the square root of x plus 5 over y cubed. Okay, and so that would be your condensed logarithm. You went from multiple logarithms and wrote it as a single log using those 3 properties. Okay. So let's look at additional one. Log of x plus 5 plus 2 log x. Okay, so going through this, I have an addition and I have a number out here. This addition is different, right? It's the addition inside the parenthesis, where when we're talking about addition, we're talking about adding 2 logs. Okay, so we cannot get rid of this addition here, but we can get rid of this addition. Okay, so how do we take care of addition? We will multiply in a minute. Okay, again, I've decided I'm going to do this 2 first, and so it just is a power. So this becomes log x squared. And then we have to get rid of all addition, all subtraction, and all powers in front. So the only thing that we have remaining is that plus, which we said all we had to do was multiply. So I have x plus 5 times x squared, which seems kind of weird. If you like it better, you could write x squared in front of the x plus 5. That's the same thing. Or if you'd prefer, you're welcome to expand it out into x cubed plus 5x squared. But those are 3 different ways we could write that, and I wouldn't say that there's any one better than the other. Okay, so hopefully right now it kind of makes sense about what we do back and forth. Okay. And again, this seems maybe kind of strange, not very useful, but it is useful when we get to solving equations. Okay, so which will happen This will happen next week, these harder ones. But okay. Let's look at one here. So number 3 of this type. So we take the natural log of x squared minus y squared minus the natural log of x minus y. We have no powers in front. We have a subtraction, which means we divide. Okay, but this subtraction here we can't take care of because it's not of 2 logs. Okay, and this subtraction we can't take care of. So we write it as x squared minus y squared over x minus y. Now for everything else, this would have been done. But something we need to check is, do these factor, and is there anything I can cross out? And in this case, this is a difference of squares. So this is x minus y, x plus y on top, and x minus y on bottom. So what's that allow us to do? Well, we can get rid of the x minus y. Okay. So this actually simplifies into just the natural log of x plus y. Okay. This only happens when you have a single log of this. Okay. If I had had another log down here, those would not have simplified. Okay. And let's try at least one more here. We have 3 log base 2 of t minus 1/3 log base 2 of u plus 4 log base 2 of v. And let's just put minus log base 2 of y. Okay. Now, if you remember something I said earlier, that if it had a minus, that means it ends on the bottom, right? It's a negative exponent. That's really useful to remember in this situation. But let's see. Let's just rewrite it a minute using powers. So log base 2 of t cubed minus log base 2 of u to the 1/3 plus log base 2 of v to the 4th. So I'm just taking all these up, right, to where they belong as powers. And then this one didn't have any. Now let's group them by their signs. So log base 2 of t cubed plus log base 2 of v to the 4th minus log base 2. I'm going to go ahead and make that the cubed root of u, because remember we don't want any fractional powers. Okay, minus log base 2 of y. So I've grouped them by their power, or their sign. And the reason I want to do that is because this is now an addition problem, which means we use multiplication. So this is log base 2 of t cubed v to the 4th. Let's pull out a minus here, and that leaves us with log base 2 of the cubed root of u plus log base 2 of y. So now I have a minus here, but what do I have here? I have a plus. So I have log base 2 of the cubed root of u times y. And then what do we do when we have a minus between 2? We write it as a division. So this is log base 2 of t cubed v4, and then the dividing of this, which is the cubed root of u y. Okay. So that's how we get it to be multiplied on the bottom. But again, if you kind of want to just remember that if it has a negative, it'll end up on the bottom. That's kind of your check or your shortcut, if you will. Okay, so that's how we go from a set of multiple logarithms to a single logarithm. Okay. And let's do one more. Okay. So how about the natural log of xz minus the natural log of x root y? Okay. This could have been written a couple different ways, but they went ahead and started with it pretty close for you. Okay. So what I see here is it's a division problem because I have a minus. So this is the natural log of xz over x root y. And when we finish, we don't want to have two letters in this, two of the same letters showing up if we can help it. Okay, so what we can do is simplify here. So we get natural log of z over root y, which is perfectly fine to leave like that. Okay, so at this point, I would also advise you to go to page 407 and try 43 through 61 odd until you at least become comfortable with those. Okay. Again, there's no assignment today, but you practice those. You let me know if you have questions. You should also do 25 more logs on that worksheet. So 51 through 75. And I've posted the answers to those. And that's just, again, to keep you comfortable with what logs are. So again, please let me know if you have questions. Tomorrow you have 12 problems to do, so at least refresh or get through some of these, practice them, and then tomorrow you can always refresh your memory with a few if you need to. So let me know if you have questions.